step one is going to be to turn the machine on. In order to turn the machine on, we've got two control boxes located over here on the right side of the machine if you're looking from over there towards the wall. And to power up the machine, you're going to rotate both of these paddles into the vertical position, enabling the stepper motors and various controllers and the spindle. All right, so to begin working with the machine, we now need to enable the Avid CNC control software. So we're going to come to the link here. That's the Avid CNC Profile Manager. Launch that. And then we can either double click on the Avid Pro 5x10 option here, or just click Launch Profile. We only have one profile for this machine, and it will load the control software. Once the control software is loaded, there are a few things that we need to do to get the machine ready to run. The first is we have to execute the reset to get the machine ready to begin motion. So when we simply press that and we go to this reset where it's framed in black, letting us know that we've done the initial reset. Once that's complete, we need to home the machine. If you look here in the control software, right now it believes the machine to be at 0, 0, 0. However, on the machine itself, we're back several inches on the X and Y axis because the machine doesn't know where home is. So our next operation is going to be to home the machine. So in order to home the machine, we come up here to this icon for home, click that. It will give us an option to jog the machine closer to home to start. The machine should have been parked in this approximate location when it was last finished or being used. If not, you could very carefully manually jog it up to this general corner. And when we're ready to start, we've hit the cycle start button, which is this green button here. Clicking this button will begin the machine's calibration so that it learns where the 0, 0, 0 is on the machine coordinate system, which is this front left corner, and the spindle raised all the way up on the Z-axis. Once this operation is complete, the machine will know where it is. And this is especially critical to do in the beginning, because if you fail to do this, you could jog the machine and actually crash it because it won't know when to slow down as it gets to the end of any one axis. Now you can see at the completion of this, we're at 0, 0, 0, up in this front left corner, spindle all the way up. Now that we've set the machine's home location, we need to warm up the spindle. The spindle should go through a warm-up cycle once a day when the machine is used. If you know someone was running the machine before you, you don't need to complete this task. However, if you have any reason to believe you're the first person to run the machine in the day, you're going to want to do this. So in order to warm up the spindle, the first thing that I like to do is push the machine down to this end, the far end on the Y-axis. So by clicking this green triangle for plus Y, I'm going to send the gantry most of the way down the table. It doesn't really need to go all the way. Then I'm going to click on the X plus to bring the spindle over into approximately the center of the table. Now I do this for two reasons. First is sound. It moves the spindle away from me. This is a loud operation. I'd rather not listen to the spindle, right next to my ear. And jogging it over into the middle of the table ensures that the spindle is safely away from any of the edges where somebody could potentially, bump into it. We do want to make sure that there is nothing in the spindle before we actually commence the spindle warm-up. So you want to make sure that the spindle nut's not in there, that nothing else is sitting loose around the end of the spindle as we go through this operation. To initiate the spindle warm-up, we click the spindle warm button here. It will ask us to click cycle start as soon as we're ready to proceed. So with the machine jogged all the way down to the end, and us having clicked the spindle warm-up button, we get this prompt to hit cycle start to proceed. Any operation where we initiate motion in the machine will prompt us to confirm we want to execute that motion by clicking the cycle start button. This is a safety feature to ensure that the machine doesn't move without the operator expecting that motion. Clicking this button will now begin the spindle warm-up cycle. Once started, it is entirely automated. It will take approximately 5 minutes to complete. So with our spindle warm-up complete, we're going to start by securing our stock to the machine. There are several different ways to secure stock to the machine. Today we're going to go over the most basic and repeatable version, which is using clamps. All right, so we have a set of clamps available here at the space. These do have interchangeable heads, so you can dial this in based on your material thickness, and you really want to be as close to the thickness of the material as possible to start. We want to line our machine or our stock up on the machine's X coordinate system. This is our X, this is Y on the machine. So I'm just basically going to follow this edge, get my stock even with it, and then bring these clamps in so they come over the edge, begin tightening. I'll keep a little downward pressure on my piece as I'm getting at least the first couple of clamps in, just to make sure nothing moves. I like to secure at least 4 corners. Planning clamp placement based on where the machine needs to run. You will be able to check this, but you want to ultimately make sure that you're not going to hit the clamp heads during the machining operation. Double check that everything is tight and that your stock doesn't move. Okay, so our stock is now placed, and we're going to bring the machine back down so that we can begin loading a bit. The most effective way to do this is in the jog control panel of the CNC software, you'll see a button called Park. We're simply going to click that button. It'll ask, because we're asking for the machine to move, it'll ask us to hit cycle start. We'll confirm. And that will bring the machine down into a safe area where we can load the bits. Now I like to load bits here because if something slips and falls, your bit will fall on the MDF table and not the concrete floor. We're going to take the appropriate sized collet, in this case 1/4 inch. We want to make sure that if there's any dust or any sawdust in there, we blow that out. We're going to start by putting the collet nut into the spindle and just getting it started. Sometimes it can take just a second to really get that thing to seat. Okay, once it does, we're going to thread it up until we feel the first little bit of tension, and then we're going to back it off a 1/4 turn. It is very important that you not try to insert a bit with any tension on the collet. Now, when we insert the bit, we want to insert the bit generally as deep as we can inside of the collet to ensure we have as little deflection as possible at the end of the bit while it's running. And while supporting the bit with one hand, I'm going to just rotate the spindle and the nut to put a little bit of tension on them. That little bit of tension is usually enough then to hold your bit. We will grab our set of wrenches. The smaller wrench goes on to the flats on the spindle itself, with the larger wrench going onto the collet nut. In terms of how tight, you just need to make it snug. You do not need to put excessive force onto the collet when tightening it down. Now, with our bit loaded, we now need to do something to tell the machine where the end of the bit is relative to its world coordinate system. So after now that this is 0, 0, we can go through and execute what we call a manual tool change to do that process. Now, I like to, when I'm doing this, load the bit that I know is going to be the first bit I call in my job. So what I'm going to do to actually begin this process is in the Avid CNC control software, there's a button called MTC located in the upper right hand corner just below the home icon. I'm going to click that. All right, and then the software will ask me what tool number this is. This should be whatever tool number is the first, it should be the tool and the corresponding tool number that you set when you've created your file in vCarve. So in my case, this is going to be tool number 1. So I'll put 1 in the dialog, hit enter. It will ask me to hit cycle start. It is going to initiate motion in just a moment. But first, it will ask me for the diameter of the tool. This is critical for the when we set the XY coordinate systems in the next phase. So in this case, the diameter of this tool is 0.5 inches. Hit enter, cycle start. It'll tell me it's about ready to head to the touch plate. So hit cycle start to proceed. When I click this, it's going to come above the touch plate and ask me to insert tool 1. Now again, we like loading bits in off this corner just in case something falls. So we don't need to do anything here. We've already entered tool 1. So I will simply hit cycle start. And now we're given an error dialog, or more of a warning dialog. In this case, any bit with a diameter greater than 0.375 will give us a warning to make sure that when this comes down onto the touch plate, that we're not going to hit this corner. All right. So any bit smaller than 3/4 of an inch, you don't have to worry about it. Simply choose option 3 and hit cycle start. The machine will now come down, touch off on this touch plate, and that will, because it knows where that surface is relative to the machine coordinate system, tell the tool exactly where in 3D space the end of that bit is. You'll see it touch once, and then a confirmation touch to make sure its measurement is correct. The machine will then retract, and we have now measured successfully the 3D position of the end of this tool. We do this because this will allow us to, in subsequent parts of the operation, to change tools and have the system just automatically come back here, calculate where the new endpoint is, and continue with the job. Our next step is going to be to set the work coordinate system. That is wherever we set our 0, 0, 0 for X, Y, and Z in our vectoric software. We have to tell that where that point is in the machine itself. So in this case, we're going to use this lower left-hand corner and the top of the material surface. In order to do that, we're going to use this touch block, and we will need to back off this clamp for right now, just so we can get to that corner. Should be fine with the other 3 clamps in place. So we begin by setting the block with this raised corner. This is how it actually registers on the corner, up against that lower left-hand corner. And then we're going to jog the machine so that the end of the bit is about 2 inches above this gold plate and roughly in the center of this block. So to jog the machine, I'll go over to my X and Y. And it doesn't have to be perfectly in the center. We just want it to be close. All right. And now we're going to go ahead and connect this wire so that we can detect when the machine comes down, when we have continuity and where the block, knowing where the block is. All right, so I've done a little extra positioning just to make sure I'm happy with that. All right, so now I will go into the set part zeros function down here on the kind of bottom of the screen. We're going to use the plate option, and you can see that it by default is picking this lower left-hand corner, which is what we want. Before I do anything, I will take this touch plate and I will gently raise it to make contact with the bit. And I should see at this point the triggered warning indicating that I am detecting when the bit touches the plate. That is exceptionally important so that we don't have a problem with the machine coming down on the plate and not knowing where it's going to end. We want to just quickly glance at this bit diameter, make sure it's still accurate to the bit we had just set. In this case, 1/2 inch, it is. And when I'm ready to actually begin the process, I will click cycle start. The machine will tell me to jog to the center of the plate, which we've already done. I will hit cycle start again. It will tell me to ensure that we have the magnet. We're asking these things repetitively just to make sure that they're done for safety. And once I confirm there, it will begin to come down and measure the Z offset. You do need to be within about 2 inches of that touch plate. Otherwise, the machine will abort if it goes down too much. And it just did a successful measure of the Z. It does, again, 2 touches. Now, in order to do X, the machine is going to always travel against this inside edge because then it pulls the probe block into the corner. And because we're using these helical bits, it's going to ask us to rotate to make sure that the flute of the bit is going to hit the edge of the block first. So I'll just rotate this as I need to. Okay, it's right about where it needs to be anyways. And I will say cycle start, and it will come in and come and touch the edge of that plate once, then twice, confirming our X dimension. Now it'll ask us to rotate the flute. So again, I'm just going to rotate that a little bit. And we'll run the same process in the Y direction. Again, we'll touch once, touch twice, and now it's completed the process. We will then retract to a Z safe height, and the bit will move over what it believes to be 0, 0 on the X. So this would be an opportunity for you to check and make sure it appears to be where we want it, to know you had a successful setting of the part coordinate system or the work coordinate system for the job. With that complete, we can put the probe block away and move the clamp back into position and tighten it down. Now we're going to begin by loading our job file. So in the CNC control software, we're going to go down again to those icons on the bottom, select load job, browse to the file that is our G code, open that file up, and now we want to go ahead and check the file itself. We're just going to look at the top of this file to make sure that it's what we are expecting. We can see our X and Y origin was set to the bottom left. We can see where our Z origin was set. We can look and make sure that the stock sizes are right. And again, we'll see this, generally we'll be able to see the first tool that we're using. This is just a good safety check to make sure that we've loaded the right file and that we are ready to begin the next operation. We can check the job and make sure it looks like what we expect by clicking the graph job function. That will bring us into this screen where we can see the G-code moves that are about to happen. And if we zoom out, what we can also see is a small circle right here that represents the tool's current position relative to where it's going to move and cut the piece out. Jogging the machine would allow us to then go through and check to see if we're going to be clear of any clamps, to make sure that we're operating well inside of our stock. Unfortunately, the preview does not automatically refresh you need to hit the escape function down here in the toolbar, kind of on the bottom of the screen to the left, and then click graph job again, and you'll see it updates that point. So now I can see that at this tool's current position, I'm going to be right about in the lower left-hand corner of the job. I can see if I bring this down on the Z-axis a bit, get a better sense of where I'll hit the piece. I can see I'm well away from my edges. I'm well away from my clamps. I'm going to jog to what I think maybe is the other corner of the piece. I will again go back, click graph job again, and I can see I'm pretty close. Move it out. And again, we're going to cycle this one more time just to make sure that, again, we are certain that we're well away from our clamps, we're inside of our workpiece, so that we can be comfortable that we won't have any collisions when we're actually running the job. All right, so we're ready to run the job. And a couple bits of housekeeping that we're going to do first. We're going to want to make sure that we remove any materials that we may have set on the table as we're getting things set up. We want to take those out. We want to make sure that there's nothing that we can accidentally run into, or as few things as we could run into as possible. All right, we're going to want to make sure we have the dust collection port open. All right, so we just want to go through, loosen this screw if necessary, pull the blast gate open, and just put a little tension back on this screw so that it can't vibrate closed during the job. We are going to put our dust collection in place. So we bring that down, it comes up and catches this corner, comes up, the hook snaps it in place, and now we are ready to run the job. So when we begin this job, there are a couple of things that we want to make sure we're ready to do. So when the job is actually running, when you initially start it, you want to make sure that you have kind of looked at and are familiar with where the emergency stop is. We want to be reasonably close to that so that if we hear anything doesn't sound right, machine makes a crazy noise, we see a rapid movement that we are worried are going to damage anything, this is our fail-safe to dead stop the machine. This will instantly kind of reset everything, so it is a button of last resort that we only click when we we would rather reset up everything than have a failure. We do have some other options while the job is running that would allow us to do a less drastic pause. If you look down here, there's a couple of options it's kind of in the center of the below the spindle and feed rate controls. One of those is called tool check. Clicking tool check is essentially a pause. If we saw, for instance, maybe a clamp wasn't quite tight enough, or we saw something that we thought we didn't need to end the job for, but we wanted to pause and fix something, we wanted to pause and inspect something, selecting tool check will allow us to create a pause in the job so that we're able to go through and see what we want to see and without having to reset and go back to zero. If everything is good and we are ready to start, we are going to start the dust collector, and then to begin actually working the job, we would hit cycle start to begin the machining process. All right, so we're starting our job. Obviously it's a little loud because we have the dust collector running. We've hit cycle start. We get our warning that the spindle is about to begin moving. So we hit cycle start to confirm. Once we do, we will hear the spindle come up to speed, and it's going to begin its job. Now, as the spindle is working, we want to listen to the noise it's making. All right, right now I can tell from this level of noise that there's not a tremendous amount of effort getting put on the spindle or the bit, which is good. We have an option at this point where we could increase the feed rate by selecting the icon, plus icon right here, to increase the feed rate, which would allow us to go up to 150% of whatever our programmed feed rate is. If we ever need to go back, if we realize we went up too quickly, or certainly at the end of this tool's job, we want to drop back to 100%, we can simply click the button in the middle that says feed 100, and it will immediately drop our feed rate back to 100%. So one of our operations is just completed, and we now need to change tools. So when it completes, you'll see a little message on the display that says heading to touch plate, press cycle start to proceed. Before we're going to do that though, again, we always like to change the bits over the table so that if something slips, we don't risk a carbide bit hitting the concrete, which will basically destroy the bit. So we're just going to jog this into a comfortable location that's again over the table to do this operation. I'm going to remove the dust shoe to expose the bit that's in there, and I'm going to take that bit out. So again, we use the small wrench on the spindle, and we use the larger wrench on the nut, and we're just going to kind of slowly release this. Again, we don't really, even over the table, want to drop a bit, but we'll loosen that nut up a little bit. Then we can loosen it by hand, take the bit right out. We'll take our next bit. I'll put this bit away. Always load your bits in bit first, so that way when you dump it out, you're not dumping a sharp bit towards your hand. We're going to bring our next bit out. Uses the same size collet, so nothing to change there. And we're just going to load that bit in. Again, hand tighten this nut, okay? Especially with the V-bit, because that point is very delicate. We want to be careful when we're tightening that up that the bit isn't loose and can fall. We will take our wrenches. Again, just snug. We don't need to go crazy here tightening. We're going to leave the dust shoe off for a moment. And we're going to go ahead and say, now it's okay to proceed over to the touch plate so that it can recalculate where the tip of this new bit is. So I'm going to say cycle start. It'll move the machine. It'll ask me again for the diameter of the bit. In this case, it's 0.375. I enter that and say cycle start. It's going to ask me to insert tool number 2. Again, I've already done that, so I'm just going to say OK. And it will come down and recalculate the Z offset, which is what we call that value of where the tip is, for this new tool. Once again, every measurement to a touch plate will go twice. It will do the initial measurement and then the confirmation. So you see 1. Then we'll come into slower 2. It is now measured tool 2. So now it will give us a message that says the spindle is about to start. Press cycle start to continue. So now is when we want to put our dust shroud back on. We're going to turn our dust collection back on and click cycle start to begin the job. Spindle will come up to speed and begin its operation. All right, so with our job done, we can see we've got, a nice, this is the job we were doing. All right, so we got a nice little tray. But now we're ready to shut down the machine. We finished for the day. So what we're going to start by doing is hitting the park button. And that is going to bring the machine back to the location we want it stored in at the end of an operation. We will take off the dust shroud. All right, we're going to take the bit that we had in there out. We do not store the machine with a collet or a collet nut in it, just to help make sure that when we do this spindle warm up and whatnot, that we don't leave a loose collet nut in the machine. So we want to take all this out when we're done for the day. Put those away. And this is where the machine will stay parked. It's kind of its default storage location. To exit the software, we're simply going to go to hit F10 or hit the shutdown menu button, exit CNC 12. Okay, that will close down the CNC software. We want to close the blast gate because many other woodshop members won't necessarily remember to check that to see if it's open. And then we can close down the laptop, and we'll come back over here to the control boxes, move both of the paddle switches into the horizontal position, shutting power off to the machine, and then we'll just vacuum off the top, making sure we don't leave any sawdust on it. We'll put away all of our clamps, all of our accessories for the machine in terms of things like clamps, collets are located in this top drawer in this cabinet. The dust collection dust shroud goes in this second drawer. And the third drawer are just some other miscellaneous clamps that are available should they be appropriate. So please make sure when you shut the machine down, you leave everything cleaner than you found it. And if there's ever a problem with the machine, reach out to Frank Aloya or Drew Jackson in Slack right away. Let us know that something's going on, and we'll make sure we give you the right advice to get it taken care of. Thank you.